Right, some general solutions continued, and let's take it up a notch. Okay, so we got 2 cos theta plus 90 equals minus 1. What do you think our first step would be here to make it look like the ones that we've done before? We've got sine theta equals a half. What can we do to our equation so that we get there? Okay, I'm kind of have the idea to say, well, I'm going to divide this whole side by 2 and divide that whole side by 2, because on the left hand side then we've just got cos theta plus 90 equals minus a half. Cool, that looks more like something we've done before. We've got this cos is x over r. We've got a better sense here, and it's just the trig function on the one side. And we're going to use the same strategy in our even more advanced ones, where we've got cos equals sine. We want to turn it into trig function of an angle equals something, minus half. Okay, now let's go for our reference angle as we've done before. So our reference angle is shift cos of minus a half. Okay, so we do that and we're happy. So we go shift cos of minus 0.5, 120. Okay, but we don't want it to be 120. We want it to be in the first quadrant. So we're going to say that it is 60 degrees because it's 180 minus 60. Okay, so there's our reference angle. In other words, we really just said shift cos of a half. We didn't do the negative. We said, no, let's just take it of, is my shortcut key not working, 60 degrees. Okay, so there's our reference angle. And we said, no, but hang on a second. It's negative, so cast diagram to the rescue. And we've got CAST, 60 degrees is sitting obviously here in the first quadrant. Cos is negative, so we must be in these two quadrants. So therefore, we've got two solutions. If that's 60 and that's 60, then 120 is our one angle. But now, careful. It's not theta that equals 120 degrees. But, yeah, theta plus 90, because that's what was in the brackets. So this whole thing becomes our kind of reference angle. So theta plus 90 is 120, or theta plus 90 is, so just this bit in the brackets is, well, if that's 60, then for our second solution, yeah, why do I abandon the colors? They're nice. Let's go all the way around there. So it's 180 plus 60, which gives us, oh, I've got a muddle in the last one, right? So let's make sure we get this right. 180 plus 60, 240. Took a dent in my confidence in the silly mistakes, but they made for some good questions in the Ed puzzle yesterday, or this morning. So theta plus 90 is 240. So we've got our two solutions within 0 and 360. Right, well, let's just solve these equations because we want theta. So theta plus 90 is 120. So if we subtract 90, then theta equals 30. Or, let's do the same thing here, minus 90, minus 90. So that gives us 150, I think. 150. Yeah, so theta is 30 or theta is 150, but we want the general solution. So what do we need to add? We need to add k times 360 degrees plus k, that should be a small k, so just to make sure, times 360 degrees, and in each case, k is hiding behind the calculator, and k is an integer. So let me just write it over here. K is an integer. So there we go. There are two solutions. Wasn't too bad actually, this idea of, well, the initial equation looked a lot more complicated. Dividing it by 2 made it quite easy, right? And then instead of theta, we had theta plus 90. Okay, let's do one more example. I'm actually going to throw it in the same video. to go, well, what happens if we're given something else? So let's take one of the examples from the textbook, and let's go tan of 2 theta equals, what have they got here? I don't like these numbers like this, but anyway, let's go for it. So we've got 147, and theta is, I'm going to change this one up there. I'm going to say theta is between minus 360 and 720 including. Okay, so we've added in a new element here. So tan 2 theta equals minus 2,147. First steps first, let's work out our reference angle. So our reference angle is just going, well, let's shift tan of this number here, minus 2,147, which calculator, I should be doing this on Brendan's calculator. So we've got shift tan of minus 2,147. Well, we said that we just did this without the minus and said 65. I'm going to go to no decimal places because that feels a lot easier to work with. So 65 degrees is our reference angle. Cast diagram to the rescue, and we've got 65 over here, but tan theta is negative. So we said, and I've got in the habit of doing this in green, so I'm just stuck on this now to go CAST. Where we're working, well, tan is negative, quadrant 2, quadrant 4. So therefore, if that's 65, then theta, one option, but wait a second, not theta, 2 theta, because that's what we're dealing with. So 2 theta is 180 minus 65. 180 minus 65, 115, 115. Or 2 theta equals, well, we must be down here. So if that's 65, then let's go for our pinky to go. If we went around there for our second solution, then yeah, it is that, right? It's quite fun. You can imagine I'm making this video and thinking of the questions I want to put in the Ed puzzle. Thought I'd share that. So minus 65. So if that's 65, 295 is our other solution. That relates to the pink. Let's make this whole thing here 2 theta. Let's make it in pink too. So we've clearly got our 2 solutions. Here, 2 theta. Okay, now to turn this into a general solution, well, we know what to do. We just add 360k. So k times 360, we add 360 because we know that this repeats every 360. As I said in one of the previous videos, you might see your friends doing this with plus 180. That's because the tan graph repeats every 180. The reason we're going for it this way is it's just things are more similar, so it doesn't matter. Sine, cos, tan, we've got such a similar way of approaching it that we find our reference angle, we've got our cast diagram, we get our 2 solutions, and then we just add k times 360 or 360k. So if you see others with a 180 or solutions that look different, your solutions could well be perfectly right, and there are different ways of writing these out. Okay, so we've got our 2 general solutions, but we've got an added part to this now. Now we're told that theta is between minus, we haven't quite finished, have we? Sorry. I'm getting ahead of myself here. We've got our 2 general solutions, and in each case, k is an integer, an element of integers. We've got 2 theta equals this, but we want theta. So we need to divide by 2, so divide this whole side by 2. So 115 divided by 2. Here we go, 115 divided by 2, 115, S to D, 57.5, 57.5 degrees, plus we also need to divide this by 2. So K times 180 now. Okay, or our second solution, theta equals this divided by 2, because we're going to divide the whole side by 2. 295 divided by 2, S to D, 147,5. 147,5 degrees, plus K times, again, we needed to divide, for this we divided that by 2, so we divided this whole side by 2. So we've got K times 180. So we've got our two solutions, general solutions. K is still an integer, but we set it up there, so that's fine. We've got our two solutions, but it's asking us theta is between minus 360 and 720. So theta is between minus 360 and 720. So the last piece of the puzzle here. How are we going to find out all our solutions? I'm trying to sit with a straighter background here. How are we going to find our general solutions? Our specific ones. Well, let's throw in some values here. So let's start with our 57. And go, we've got 57, 5. Let's try and get the smallest value we can. So minus, let's say that K were minus 3 times 180. S to D, minus 482. That's too big on the negative, right? So let's change this and say, what about 2? Minus 302,5. Does that fit in here? Yes, it does. So one of our thetas is minus 302,5. Okay, what happens? So all we're doing is replacing K with different numbers in our first one. So minus 1 times that, S to D, so I can see minus 122. Does it fit in this range? Yes, it does. So we've got a whole lot of options. Minus 122,5. Okay, let's keep going. What happens if K is 0? Well, in other words, we're just going to be sitting at 57,5. Yes, that's here. So 57,5. Do you get the idea that we're just replacing our K and saying, well, now K was negative, let's make it positive, plus 1 times 180. 237, still within our range, 237,5. And we can keep going. It's quite a big interval there, lots of solutions here. 417, yeah, still within our range, 417,5. Keep going. 3, 590, still there, 597,5. I'm purposely not putting questions in between here because you can leave this playing in the background while you punch in all the values. 4, 7, finally we're too much. Okay, so this was just this one. Now we need to do the same for this. So let's keep going and go 147. So now we're looking at 147,5 minus, I don't know where we're going to start, so let's go 4 times 180. So first value of minus, nope, too small or too big on the negatives. So let's go there. Minus 392, still too negative. So we're looking at this equation, 147,5, and we're trying different values of K. Okay, so we're going to do this. Now, this is going to be somewhat tedious, right? Let's keep going. I'm going to start this over here. 212,5. And so we go. I need one of those little things that speeds everything up here. Minus 32,5. See? This is fun, right? No, too big, right? Finally. Oh, geez, where did we come from? So they're all our answers. Theta equals all of these things over here. And we could maybe have said, let's look at this and say, well, y equals, what was it? Tan of 2 times x. And let's get rid of this. So if we've got that and we ask ourselves, when does that equal minus 2 comma, so when does y equal minus 2,147? Well, it was at all these points. So what we've just worked out is to say, here's tan. Look how often it's repeating itself. And we found out all of these points to go, well, there was an answer 57,5. Was that one of our answers? Hopefully 57,5. There it is. So there was one. And we found out all these answers here. Well, if I could hit the things. We're finding all of these. Wherever y was that. And here are all our solutions that we found. And for theta between those two big values. So that is that. I don't have a guitar or anything for you, so lucky you. Goodbye.